More asymptotes of functions. Let's find the vertical and horizontal asymptotes. Again, to find horizontal asymptotes, we need to take a limit as x goes to infinity. Well, as x goes to infinity, this first term here is going to go to 0. However, this term right here, this negative square root of x, is going to go to negative infinity, because the bigger x value we plug in here, the bigger the square root of that x value is going to be. So this limit as x goes to infinity is going to approach negative infinity. That does not give us a horizontal asymptote because that is not approaching a number. The limit of this function as x approaches negative infinity, well, this piece right here would go to 0. But you'll notice that this piece right here doesn't really make any sense. If x is a very, very large negative number, well, we can't take the square root of a negative number. It's not real, so this limit does not exist. Again, that does not give us any horizontal asymptote, so we have no horizontal asymptotes. And as far as vertical asymptotes go, again, those occur when the limit as x approaches some number of our function is positive or negative infinity. How does that happen? Well, typically it happens when denominators are made to be 0. If the value of a denominator is 0, at the same time that the value of the numerator is not 0, then we have ourselves a vertical asymptote. You'll notice that the limit as x approaches 0 from the right of this piece of the function is negative infinity, and as x approaches 0 from the right, this piece of the function is just 0. So this limit as x approaches 0 from the right is going to be negative infinity, and that implies that we do have a vertical asymptote at x equals 0. Now, why did I choose x approaching 0 from the right? Well, because x couldn't approach 0 from the left because of this square root function. We're not allowed to have negative numbers in here, so we had to take the limit as x went from the right. Either way, we found that x equals 0 is a vertical asymptote, because as x approaches 0, from the right in this case, the limit approaches negative infinity. Okay, good job.